Hello, we're pulling into the station, the Kinematics station. And what I want to do is I want to expand my previous inverse kinematics example. I don't know if expand is the right word, but I want to change the way it works in a way. So first of all, this is the exact same example that I built in a previous coding challenge, but I've changed a few things. I've gotten rid of the, there's only a few segments now. There's only 3 segments. The segments are longer. And I've also gotten rid of that thing where the stroke weight of the segments changes. So it has less of an eel or a snake-like quality to it now, and it's just kind of has more of a robot arm-like quality. Because what I want to look at is what happens if I take the base of it, this right, and lock it to a certain point, much like an actual real robot arm would do. So what if you need to figure out the kinematics for a robot arm to reach out and grab an apple because the robot likes apples? That would be a great robot. People should make just robots that like apples. Anyway, I had a point to this, which was, and so how would you do that? And so this is how we're going to do it. Now, first of all, I've got a little secret to tell you. I actually just tried to do this, and I completely over-engineered and wrote some really spaghetti problematic code. I will link to the live stream where I did that, and through writing that code, I really realized this is a time where it's just going to be so much easier if I just use an array. So it's kind of interesting to explore this problem as this kind of linked list thing where each object keeps track of its parent and its child, and I did that in the forward kinematics, but it's kind of unnecessary because the segments are just in an order. And if they're in an array, all I ever want to do is iterate through them forwards or backwards and know which ones are next to each other. And an array is going to just make that so much easier. So let's talk about what I mean by that. So this is what, remember, this is what inverse kinematics does. So let's say this is the sequence of segments, and this is a particular target. Let's put the target up here. This is a particular target. So what this segment in the previous example is going to do is it's going to turn to point at the top target. So it would do this, and then it will shift its position all the way to here. This is if it can, if the base is not locked and it can move. Then this one will turn to face the beginning of that, and then it will move to there. So that's what we did. So what we're going to do to lock the base, and this sounds like overly simplistic, but it works from what I understand, is I'm going to do that with all of the pieces. So maybe I get this one here and this one here, and then after I do that, I have kind of a new arrangement, and then I shift the whole thing back. So just shift the whole thing back, we're done. I'm going to move this back here, then move this, then move this. And there's probably some very easy ways to do that. I'm not so sure if I'm going to end up doing it the simplest way. I'm sure, this is really, today feels like a lesson in refactoring, which is, just writing the code to get it to work and then reorganizing and simplifying it and trying to do that a little bit. But so this is the basic idea. So let's start going to the code and let's make an array that each one of these segments has an index into that array. 0, 1, 2, and 3. 0, 1, 2, and 3. This way, I could just do inverse kinematics by iterating over this way, and if I need to iterate through it forward, I can do that way. I always know the base is 0, and the last one is in the length of the array minus 1. It's going to make things so much simpler. Okay, let's try this. Here I am. Okay, so I'm going to make an array, and I'm going to call it let's call it tentacle. It's fine. The array is still called tentacle, and I'm going to say tentacle index 0 is a new segment. So I make the first one here, and then it's probably still useful to have them keep track of their parent. I don't know how necessary that is. Let's actually comment that out right now. Actually, let's keep the parent thing because that is a way that I position the next one, which is kind of useful. So let me keep that for a second. Bear with me. So I'm gonna get rid of the child thing. I sort of have a suspicion that keeping the parent might be useful, but the child thing is kind of unnecessary, but I don't think I'm using that. So I'm just going to refactor to do the same thing first. Then what I'm going to do is I'm going to have this loop start at index 1. So I'm going to go from 1 to 3, and I'm going to say tentacle now index I, and I cannot spell tentacle. Tentacle index I is a new segment made from tentacle index I minus 1, which is the previous one. Oh, this is so much better. Forget about the child thing, forget about next. Forget about this. Look at this. Oh, I feel so relieved. Oh, Oh, I feel so relaxed now, thank goodness. Oh, this makes so much more sense to me. Okay, so now we've got our array. And then what should follow the mouse? So tentacle, so I'm going to just say end is tentacle length minus 1. So the tentacle, and actually let's have that be a segment, is the array, the last spot in the array. I could use an array list and use pop, or there's probably some other fancy way to do this. I cannot spell tentacle, it's such a hard word to spell. Okay, so that's the end segment. And so now I just say end follows the mouse, and I'm going to move over here a little bit. End update end dot show. Okay, I don't know that I need to do it all this way because ultimately I'm going to loop through everything. But now what I do is I want to iterate through them backwards. So what I want to do is say for, sorry everybody, I've got a little sound thing going on here. For, I want to start at the end of the array, I equals, I just want this to be in a variable. Int length, int total, because this is going to make my life, I'm really now trying to make the code simple. Total is tentacle.length, and so the last element is total minus 1, and I'm going to start from total minus 1. No, I'm not starting from total minus 1. I'm starting from total minus 2, go all the way down to 0, I minus minus. And then what I'm going to do is say tentacle index I follow update show. And the reason why this is useful is follow knows how to, it follows its child. So that's the relationship that I need, not the parent, it seems. But you know what? Guess what? I don't need the child because I can tell it which thing to follow. Right? What if I just give it a segment to follow? And then here, I know what its child is. You know what its child is? It's tentacle I plus 1. It's the one after it. So this is so much nicer because I don't ever have to keep all these references because I can just have them, I know that the one after it is the one that it should follow. Great, so this should be the same. Oh, I have a mistake, which is no surprise. It would be nice if I actually created the array. In Java, you've got to be quite strict about these things, and I want an array with, how many things do I want? 3 total. And I want to say tentacle.length. And it's not an array of tentacle objects. It's an array. It's very confusing, but it's an array. The array is called tentacle. The objects in it are segments. Okay. Yes. There we go. Look, I've got the same exact thing, but I just feel so much happier about the code. I feel so much less stressed out. Now, one thing is, did I use parent anywhere? Do I use parent anywhere? Not really. I mean, I use it here in that that's how I get its initial location, but I don't use it anywhere else. So I can pass it in, but I don't actually need a reference to it, just to simplify things. Okay, so now I've really made things so much simpler. I feel so much happier. So now what I can do is I can introduce this idea of a base. And what I mean by base is where the thing is attached, fixed. So I want to have it be attached to the bottom. So I'm going to create an object called a p vector object, which is the base. And I'm going to set the base to be equal to a new p vector, which is in the middle and at the bottom. Okay? There we go. A new p vector, which is in the middle at the bottom. Yay! Okay, feeling good about this. Then what I'm going to do is, after I do all this nonsense, I want the thing in the array that's first, the first element, which is tentacle 0, and I want to set its location, set A, its start and end point. I want to set A to the base. So I want A to be the base. And so I'm going to write a function called, and actually I think I want to put this function near calculate B, set A, and it's a little bit, this is a little bit overkill to just have a function just to do this. But I'm going to say A equal, but I'm doing this because, you know, I think there's a way to have the object's endpoint always one object's endpoint always has to be the other object's beginning point. So I think I could probably link those. But I'm a little bit afraid to do that. So I'm going to copy the data, copy this vector to this one just for now. Maybe later we can do that. Okay, so now that I've done that, what I want to do is set its base. Okay, let's do that. Now, okay, so first of all, why don't I, didn't seem to work. Well, setting it as its base doesn't really do anything because up here, as soon as I update it, it's going to attach to the thing that's moving. So one thing is I want to, I think I want to just take out show here, and I want to have a separate function for rendering everything because that's just going to make everything much, much easier to deal with. So if I do that, we can see that this works. But look, this is not a realistic robot arm because the bottom can just stretch to wherever it needs to go. Because all I've done is set the base to the bottom, but I didn't change B. So what I need to do is whenever I change A, I need to also update B, which gets done in this function calculate B, right? Remember, it uses that polar to Cartesian coordinate transformation to set B based on where A is and the angle. So now that I do that, you can see, well, it's attached to the base, but the rest of the stuff could just go and do whatever it wants. So now, what I'm going to do, and some people are asking why not use a for each loop, and you do see me use this enhanced loop in Java, but the reason I don't want to do this now is because precisely this. I want to now say for int I equals 1, I is less than total, I plus plus. I want now tentacle index I set A to tentacle index I minus 1. I need let me just type this in here, dot B, right? What is this doing? What did I miss? That's total, it's tentacle. What I want to do is I need, when they're detached, I need this one's A to be set to the previous one's B. And remember, they're ordered like this in the array. So that's what I'm doing here. So I think this is a much nicer solution to just say set index I, have its A be equal to I minus 1's B. I think I did this right. I want to play like a drum roll or something, but let's just see. There we go. Look at this. So now I have this robot arm that's following the mouse. You can see that it's always, if my mouse is an apple, it's going to reach up to pick it. Now it can't go very far. I could easily make the segments longer. I could make the segments longer. Well, how would I do that? I could make them, oh no, so first of all, let's add something. Let's say length. Is length a variable somewhere? Let's make them 200. And let's also figure out, well, up here is how many segments I want. So we could see here, this is what it looks like, right? If the segments are, let's try another length, 300, there's probably nowhere in this pixel space that I can't reach. Now, I don't know what it is exactly that I'm doing. And I think it might be a little bit more interesting to look at this if they were actually smaller and that there were a lot of them. And here now we can see, whoa, there's 30 of them, but they're really small. Let's make them a little bit twice as long. So you can see now I've got this thing that's kind of reaching to try to catch up. And you can see, you could imagine, now here's the thing. What if where the mouse is, what if it's following not the mouse, but what if it's following some oscillating pattern or a bouncing ball or some other physics system? You can see what the possibilities are. So what I'm going to do in the next video is I'm going to take this example and package it into an object, and then I'm going to make a bunch of them that follow some type of sine wave or noise or something to see what that gets. Okay? So I think this video made sense. I'm so happy about using an array, and I'm happy that you watched it. I feel like I wish I had an apple. I've got all this stuff here. I'm going to go have an apple later. I do like apples. Okay, goodbye.